So far we have seen the data-driven approach, the nearest neighbor classifier, the linear classifier. Now let us look into something which is more complex, more real, more of the kind of networks that we will actually use in the real world. So let's now look at these neural networks which are made up of multiple layers. So that linear layer that we saw, that linear classifier, you can think of that as this neural network with just one layer. But now we want to use multiple layers, right? In this example that we will look at has 5 layers. And what we will do is we will look at the forward prop, and then we will look at the backward prop. So forward prop is essentially how your data gets transformed to the output, meaning how you get y from x, and then we will also look at how we learn the weights, how we look at the output, the ground truth, and based on the difference and the loss that we have learned in the previous sessions, how do we back propagate, how do we essentially do that gradient descent on the weights. So let's assume that this is what our neural network looks like. We have the input x. The input x goes into the first layer, then to the second, and so on, and then finally we get the output O. Now we have layer 1 which have these trainable parameters W1. We have layer 2 which are so called activation functions which usually do not have learnable parameters. We will later also talk about why do we even need these activation functions, right? The short answer is because we need non-linearities, because otherwise everything collapses to be one linear layer, but we will talk more in detail when we talk about activation layers. For now, I just want you to see how we backpropagate through these activation layers, and this is why we have it. Right? So we have the activation function in layer 2, and then we have our layer 3, which is again it's again something. So it's, you can think of it as your linear classifier. It can be a convolutional layer. It is basically a module which has learnable parameters. Then we have another activation function, another activation layer, finally another layer which we have which has learnable parameters to get us our output O. Now if we were to write it mathematically, the way we want to write it is, let's say we have our input x, right, and this input x is a n-dimensional vector. So we have our input x, and this x is a n-dimensional vector. So we write it like this, which means it's coming from a set of real numbers and of dimension n, meaning your x essentially is a vector of size n cross 1. Now we call the first layer f, and the f, what it takes my input x, and it has these parameters w, and what it gives a1 as output, meaning it gives me this a1 as output. So a1 is this function of x comma w1. Then the output of this first layer is a1. This goes into the next function, which is we call g, right, and this has no learnable parameters. So g takes in a1 and gives us a2, right. So g gives us a2 here. Now we have h, so we call this one, the third one h. H takes in the last output a2, so h takes in a2, and it has these w3s, which then gives us a3. So h gives us this a3. This a3 then goes into j, let's call this j. This gives us a4, so we get a4 here, and now our k. So now k essentially takes this a4, right, it takes this a4, and it already has these w5s from here, and it then finally gives us our output. So it gives us the output here. Now if you think of this, so this is the forward prop, and you can think of this as one big composition of function. If we were to write all of this, if we were to write our output as one long equation, one long function, you can start with the first one. You say, oh, my x A and W1 give me, so this one actually is A1. Now this A1 goes into G, right? And then G gives you A2. So what G will give you is A2. And then this goes into our next one and so on. So this is A2 and so on. So this whole neural network, the forward prop or the function that this neural network encodes can be thought of as a composition of function. Essentially, you do one function, then the output of this function you put it into another function, then the output of that function you put it into another function, and so on until you get the output. So you can think of forward prop as nothing but a composition of functions. That's it.